So again, this is the last section. So this is 5.3. It goes with 5.3 in your chapter 5. Chapter 5 is 5.1, 5.2, and then 5.3. That's how I try to do the notes. So every note that I give you is another section, every set of notes. So 5.3 talks about conditional probability. Conditional probability. We're going to talk about what that is and how to solve those problems. Okay, so going back to a little bit of review. Formulas. The big two formulas that we're going to use this chapter are the general addition rule, the OR rule, and then this one here. Okay, this one here. Luckily, you don't have to memorize them because they're on your sheet and they will be given to you on test day. Okay, so you don't have to memorize them, but you have to know how to use them and when to use them. That's the hard part. Changing words and to fit into symbols. So instead of using A and B, fitting it to our question, whatever it is. Like I think yesterday or last time we did notes, it was like Taco Bell and Chipotle. So instead of putting A and B, I put T, B, and C. Using the same structure, just changing letters around, it helps. It helps because it's easier to remember what TB is than what A is. What was A again? But if you see TB, that's Taco Bell. C is Chipotle. Kind of helps you. It's in context. That's what I mean by changing words into symbols to fit the formulas. Venn diagrams, we've done that before. Two-way tables, like you did on your homework, like the one we just did right now. Okay. Tree diagrams, new one. Tree diagrams are new. We're going to talk about tree diagrams. And then using any of the combination. Rules in Venn diagrams, rules in two-way tables, rules in tree diagram, using the combination of them. That's what you're going to use. So anytime you're doing a problem, go back to one of these guys. If you're not using one of these guys and you're stuck on the problem, try using it. Now, do you need to use these guys for every single problem? No. Some of the problems you can do without them. But if you're stuck on them and you haven't tried one of these, or if you've only tried one or two of them, try the others. Okay, try the others. They'll help. Okay, so conditional. What's conditional probability? Conditional probability is when we are trying to find the probability that one event will happen under the condition that some other event is already known to happen. Something already happened in the past. Knowing that something already happened, what's the probability that this happens? Knowing that I already studied for the test, what's the probability I pass the test today or do well on the test? That's what conditional probability is. Given that something already happened, what's the probability I do this? Okay, that's the condition. The condition, there's always a condition with conditional probability. So here we go. We got two formulas, mainly the first one. I don't know why it's labeled 6 and 7, but the one, the first one, the first dot, is if they are independent. We don't really use that one a lot because they won't tell us if they're independent. The one we use is the second dot. I'm not even going to focus on that one. This is the one I'm going to focus on because this is the one we're going to use most often. Okay, this is the one we're going to use most often. So the big thing that you notice, or you might notice, is that there's a line in between A and B. A lot of people think that's division. It's not division. It's a symbol. It means something. What does it mean? It means given that something already happened. So what this question is saying is, what is the probability that A happens? Given that B already happened. B's already happened. What's the probability of me getting an A on the test? Given that I studied. Or given that I didn't study, right? Something's already happened. So that's when we use given that. So again, remember how I told you guys last set of notes? What was the most important word that we've covered so far in chapter 5? Or, two letters, smallest word, or, right? Or tells us we use this formula here, right? The or formula or the general addition rule, right? Or is the most important thing so far. I'm going to add another one to that list. Given that, a phrase this time, given that. It's a condition. Something's already happened. Anytime you see that, you're going to use the general multiplication rule. Go right to it. Go right to it. Anytime you see the word, the phrase, given that this happened, what's the probability of this? Just like or, you go right to that formula, you're going to go right to this guy right here. Okay? It looks a little more confusing because it has a division. It actually has division. This is division right here. This part right here is division. Oops, right here. This part is division. This is not division. It means given that. Okay? So you find the probability of both of them happening over the probability of B happening. Divide, you get your answer. Okay? So what is the probability of event A happening given that B already happened? That's the condition. B has already happened. Okay? Okay, so the other big thing that we're going to talk about this chapter is something called independence. We kind of talked about it last time, but now we're going to really get into it. Independence. Two events, A and B, are independent if knowing that one occurs does not change the probability that the other will occur. Okay? So for example, knowing that I studied for the test, is that going to change my probabilities of doing well? So knowing, like someone walks in, they say, I studied for the test. Knowing that they studied for the test, is that going to change their chances of passing the test? Yeah, right? So they are not independent. So studying for the test and passing the test or doing well on the test, those two events are what we call dependent, right? Because they change the probability. Okay? Knowing that it's going to rain today. Let's say it's going to rain today. Hypothetically, I'm not talking it's actually going to rain, but let's say it rains today. Knowing it's going to rain today. I already know it's going to rain today, or it already rained. Is that going to have any effect on how I do on the test? No. So we would say those events are independent. Independent. Okay? So how do we check to see if something is dependent or independent? Right there. You use that formula there. Use that formula. It kind of looks like the one we just looked at, the general multiplication rule. It kind of looks like that. Okay, that's how we check independence. They're going to ask you, are these two events independent? You're not even going to think about it. You're going to go right to this guy, and we want to check to see if this is true. Well, how do we find this part here? How do we calculate this part? Looks familiar, right? We use this formula, right? You can substitute this guy for here because they're literally the same thing. So is that equal to the probability of A? If they're equal to each other, they're independent. One has no bearing on the other. If they are not the same, then we say they're dependent. They're dependent. They're not independent. Okay, one does have a bearing on the other. Okay. Okay, so all right, so let's get to some problems now. I started with some that might look familiar. Venn diagram problems. Venn diagram problems. Okay. I want you to do A and B. I want you to do A and B right now. I started out with Venn diagram, because you've done Venn diagram. So I'll give you a hint. Use a Venn diagram. Okay? Do A and B. Just A and B. Stop right there. You don't have to go to C if you want to. You could do C, but just A and B. Okay, so keep going. I'm just gonna get started because I'm gonna like preface it a little bit. I wrote the symbols. See, I see change the letters to symbols. That's what I mean. Instead of using A and B, I use C for Cornell and P for Purdue. It helps. Trust me, it does help. Okay, because if you use A and B, well, what was A? Was A Cornell? Was A Purdue? It just makes it a lot easier. Okay. So the first one says probability Megan is not accepted to either. So she can't get into Cornell and she can't get into Purdue. It's not one or the other. It's not both. That's an and. Okay, so I have to fill out. So in the green, or it says in both, the probability she gets accepted to both is 20%, 0.20. So that's why I put it in the middle, right? How many total has to be in the green circle? Total in the green circle. Green is Cornell. 40 has to be total, right? Which means I'm missing 0.2. So that one has to go in there. How much total is supposed to be in the Purdue circle, the yellow circle? 0.5. So that means I'm missing 0.3, right? So there's a 0.2 chance that she gets into just Cornell, a 0.3 probability that she gets into just Purdue, but the question is asking for neither. Where is that going to be? Where is neither going to be on in the diagram? Outside the circles, inside the rectangle. So I have, how much do I have accounted for? 70%. So that means a 30% or a 0.3 probability is not accounted for. That represents not either, because they're not in Cornell and they're not in Purdue. So there's a 0.3%. I said, what do I say? That 0.3 probability, 30% chance. Okay. I could have used a formula to do that, but it's just easier when you have a picture in front of you. What is the probability that Megan is accepted into Purdue? So Purdue is okay. So yellow circle is okay, but it can't be in the green. No Cornell. 0.3 as well, right? That's this guy right here. Okay. We've done that before. This part we've done. Question C is a new one. Question C is a new one. What is the probability Megan is accepted into Cornell given that she is accepted to Purdue? One of those things already happened. One of those things has already happened. Which one has already happened? Given that she's accepted to Purdue. There you go, right there. Given that. That's the part you should be highlighting, underlining, whatever you need to do to show that, hey, that's the guy. This is the thing that already happened. In other words, this is the question here. What is the probability of Cornell? That's what they're asking. Given that it's already happened, Purdue's already in, she's already in. So when you see given that, you're going to use the general multiplication rule. Okay? First thing I'm going to do is I'm going to rewrite it without A's and B's. I'll say, so what I'm trying to find is the probability. The question itself is saying Cornell, right? They want to know what's the probability of Cornell. So that's going to go first. The question always goes first. The stuff that already happened goes second. So it's saying, what's the probability of Cornell given that she already got into Purdue? So now I'm going to change those A's and B's that I saw earlier. Since A came first, that'll be C and P over the probability of P. C took the place of A. So anywhere I see an A, I put a Cornell. P took the place of B. So anywhere I see a B, I put Purdue. That's the formula I'm going to use. Okay, so now what I got to do is fill out those. So the top, what is the probability she gets into Cornell and Purdue? 0.2, right? They told us that. That's going to go on top. What's the probability she gets into Purdue? 0.5. They told us that. Use your calculator. What do you get? 0.4, 40%. Done. Okay. Anytime you see the words given that, change them, use that formula. Change the A's and B's to whatever you need to fit and use the formula. Trust me. Don't try to think about it. Anytime you see that, go right to the formula. Okay? Yeah. Yeah, you could have done that too. You could have just, there's different ways to do it. And some people can do that. Some people can look at the table and answer the question. Most people can't. Most people I found can't do especially the given the conditional probability. So I tell everyone to use the formula, but is that the only way? No, that's not the only way. I've had more success with students using the formula than trying to do it in their head. There are students who can do it in their head. I'm not saying there aren't, but the formula will never let you down. So that's why I always say stick to the formula. But like I said, there are other ways. Yeah, there are other ways, definitely. Okay. Okay, so now here we go. Are the events accepted to Cornell and accepted to Purdue independent of each other? So what they're saying is, if she gets accepted to Purdue, does that change her probabilities of getting accepted to Cornell? I would think no, right? I would think not, because they're different schools. They don't talk to each other, right? But how do you check it? Right here. That's how you check it. Okay? So right there, we're going to use that formula, which is on your notes right here. So for this one, which one's A, which one's B, it doesn't matter. Doesn't matter which one's A, which one's B, as long as you're consistent. So as long as A is the same on both sides, you're good. Okay? So you don't have to use this one A, this one, no, it doesn't matter. So you want to choose Cornell as A, great. Then Cornell has to go here and here. You want to choose Purdue as A, then it has to go here and here. Okay, so that's what we're going to check. Well, didn't I already find one? I already know the answer to this one, right? The answer to this guy is 0.4. So I don't have to do any math. So I'm just going to use that. I'm going to use Cornell as A, Purdue as P. I have to make sure that equals the same as that number there. So A was Cornell, so that means Cornell is going to go on the other side. Probability of Cornell. Okay. I know this guy right here from part C is equal to 0.4. Now go up to your table. What is the probability of Cornell, her getting into Cornell? It said 0.4, right? So we would say they are independent events. Makes sense. Logically, it makes sense. Cornell's in New York State. Purdue's in Indiana. They're 1,000 miles apart, right? If I send an application to Cornell and then I send an application to Purdue and then Cornell calls me up and says you're accepted, that's not going to change Purdue. Purdue's making their own choice, right? It makes sense, but this backs it up. This is proof that it backs it up. So anytime they ask you, are they independent? This is what I want to see. This is what I want to see. Okay? Don't use logic, use the math. The math will tell you if they're independent or not. Okay? All right. Okay, so now let's do some more conditional using a table. Using a table. They give us this table. This one they gave. Later on, they won't give us the table. But this one, they gave us the table. It's already done. Metals, gold, silver, bronze, country, United States, China. Okay? In the 2016 Summer Olympics, the United States and China won the most medals. Suppose we randomly select a medal from the 191 that are represented into a table. Event G is going to be a gold medal, probability of a gold medal. Event U is going to be United States, probability of picking a United States person from the United States. And event B is going to be bronze for the probability of a bronze medal. They've already told us that. So now we have to find the probability of B given U. Given U. U's already happened. U has already happened. So go right to the formula. Change A's and B's for B's and U's. Okay? Probability of B and U over the probability of U. I changed A's. Anywhere A's I saw in my original formula, in this formula here? Anywhere I saw an A, I changed that with a B. Anywhere I saw a B, I changed that with a U, because that's the letters they want me to use. Okay? And I don't know if they're independent events. I haven't checked that yet. So I have to use this formula. If you use this formula, you can never go wrong with. The general multiplication rule, you can never go wrong with. The only time we use this formula is when we know for a fact they are independent. Very rarely will they tell you that. Very rarely will they tell you that. Most of the time, they won't tell you anything. So you're going to use this formula here. Even if they are independent, even if they've told you, hey, they're independent events, you can still use this formula and it'll be okay. So that's why it's called the general multiplication rule, because it's used the most often. Okay, so here we go. Top is probability of B and probability of U. So what's the probability of a B and a U, a bronze and the United States? Where is that on the table? Let's see, bronze is right here, United States is right here, so they meet right here, 38, right? 38 out of 121? Not 121, sorry. There you go, 38 out of 191. Don't change it to a decimal, do not change it to a decimal, leave it as a fraction. Don't round until the end, okay? All right, now the bottom. The probability of you, the probability of someone from the United States. 121 over 191. Okay. Okay, so don't round until the end. A lot of times this is what people will do. They'll round this and they'll divide that round it, and then divide them, and then they'll get a number and that doesn't match A, B, C, or D, or E, and they'll be like, I think the answer key is wrong. No, just don't round to the end. Okay? So how do I do it then? You use math. How do I divide fractions? 3 words. Keep, change, flip. You keep the top one, you change the bottom one, or you change to multiplication, and you flip the bottom one. What will cancel out nicely? The 191s cancel out nicely, right? So you're left with 38 over 121, which that you will put into your calculator and give me a decimal. And you go 3 spaces, make sure you round. 3 spaces, make sure you round. So 38 out of 121. 0.3140. 0 says stay, so 0.314. Okay. What does that number mean? What do the B's and the U's mean? Okay, so what does that number mean? What is 0.3? It's a probability, but a probability of what? So the probability of what? Given that that's a U.S. citizen, it's a person from the U.S. So we're going to write that in a sentence. The probability of a bronze medal given that it is a U.S. athlete is 0.314. Knowing I already know it's a U.S. athlete. I already know it's going to be a U.S. athlete they're talking about. Given that it's a U.S. athlete, what's the probability it's a bronze medal? 0.314%. Okay. Okay, so given that the chosen metal is not a gold metal, what's the probability that it came from the United States? So how would I write that? Give you a hint. There's going to be one of these guys. Yeah, we're going to have to write a C on this one, right? So not a gold medal. Is that the probability question or is that the given part? It says given that that happened. So that's going to go over here, gold with a C. What is the probability that it came from the United States? U. So that means, because it's saying not gold. If I just put a G, it would mean gold, but it's talking about everyone else. So all the other metals, silver and bronze. Okay, and then the probability of not gold. That's what it's asking for. Okay. Okay, so let's go look at the table. Let's go find this one right here, United States and not gold. In other words, United States and bronze and silver. Okay, so United States, bronze and silver. These two guys right there. So if I add those up, I get 75 out of 191. Good. So 75 out of 191 is going to go on top. Over the probability of just not gold. So go to the table. Where do I look for not gold? These guys are the not gold, right? So there's a lot of numbers there. I only want to add 2. Which one am I going to add? There you go. These guys right there. So 119? 119 out of 191? Keep, change, flip. 75 out of 119. Or sorry, yeah, 119. 75 over 119. 63.630. 2, so it'd be 0.630. Okay. Yeah. Yes. It's your method. It's your method on each question is worth, 2 or 3 or 4 points. You only get 1 point for the answer. 1 point is designated for the answer. The other 2 or 3 or 4 points are from your process. So that, yeah, I would say if you're going to miss anything, it's the answer. It's you're only going to miss 1 point for the answer. If your process is correct, and even this is even better for AP stats. Let's say you did all of this correct. Let's say I did all of this correct. So let me hide this part here. Let's say you did this, showed this work here. And when you put it in the calculator, you got something like this. Point, I don't know, 543. It's not the right answer, right? AP will actually give you full credit. They will give you full credit because what's the error you made? Calculations error, right? And what'd you probably use for that? A calculator, right? So what they say is this is a calculator error, user error, right? They're not grading you on how well you can use your calculator. They're grading you on how well you can answer this question. And you technically did answer this question because this is correct, right? For some reason, maybe you pushed the wrong button or something. This answer is wrong. So they'll give you full credit for that. They'll actually give you full credit. So that's another reason to show your process, because sometimes that'll happen. You're going so fast that you push the wrong button, right? On multiple choice, there's nothing we can do. If you select the wrong answer, you're out of luck, right? But on free response, calculation errors, you get full credit. Okay? Because again, they're not testing you on how well you can push buttons in a calculator, or how well you can divide, or how well you can add, or how well you can subtract. That was, you got tested on that a long time ago. This is answering the question, and you technically did. Okay? So yeah, that's another reason why you want to um, show work. Okay? Okay, so number three. Do number three. Do number three. I'll let you guys do that. Okay, so given that a person uses Pandora, it's already happened. That means it goes after the little slash. What is the probability he or she uses Spotify? Okay, so that's the question. Spotify. What's the probability of Spotify? So S comes first, P comes after the slash. So that means the probability of both over the probability of just P, right? You could use this is kind of a tree diagram, or not tree, Venn diagram type problem. You don't need to draw a Venn diagram, but it's it might help if you get stuck. I would stick to the formulas because this is pretty clear in terms of which formula you're going to use and everything like that. And also the formulas will never let you down. Sometimes a Venn diagram, you'll draw it correctly, but you might look in the wrong spot. So it's good to help, but it's not, I would stick to the formulas as much as you can. Okay? So on top is probability of Spotify and Pandora, which is 24. So we're going to change that to 0.24. Over the probability of just Pandora. 6/8. We divide and round. Say it again. No, not on this formula. Not on this formula. Okay. So 0.24 divided by 0.68. 353. Yep, that's what I got. 0.353. Okay. Okay. That's why formulas will never let you down. If it's a given that, go to this formula. Use this formula. Okay. If it's an or, use the general addition rule. Okay. This guy here, last one. Probability of male and math independent. It's the same table we looked at last set of notes, except they asked us different questions. So it's gender versus what is their preferred subject matter. Okay. So the probability of male, I'm going to use the word male because they're both M's, and math. Okay. Again, for independence, it doesn't matter which one comes first, which one comes second, as long as you're consistent. So whatever comes first, that's also going to come here. So if you would have switched them, math first, male second, then you would have also switched the second one. It would have, instead of male, it would have been math. Okay, so easier one is probability of male. What's the probability of male? 10 out of 25, right? We've never done this one using this guy here. Use the formula. Don't even think about it. Use the formula. Male given math equals probability of male and math over probability of the second one, math. Okay. So male in math. Male in math is 8 out of 25. Math total is 20 out of 25. Keep, change, flip. We get 8 out of 20. If I was to change them to decimals, would they be the same? The answer is no. I don't think. Let's see. 10 out of 25. Nope. Oop, 25. Yep. Oh, actually, they are the same. They are the same. 4/10. 5. Wait, no, not 5. Divide by 5, you get 2/5. Yeah, they are the same. So they are independent.